Hello everyone, welcome back. In the last lecture, we tried something which was meshing around this particular geometry, and we found that in order to have mesh layers around certain corners, we have to use internal faces and we have to add layers on those internal faces in order to get layers to form around those corners as well. Now today we are going to try some more geometries of this shape only, but with some large skewness as well as some high aspect ratio. First, I'll show you a geometry with high aspect ratio and we'll see that how our meshing is going to change. We'll see that what meshing strategy we should use in case of high aspect ratio geometries. Let me go here and first change this, which is the geometry here, the triangle. Here I want this to be very large, the third point, which is at z direction. This is at point 1. Let me just confirm if we are doing the same geometry. We'll take this starting from negative 0.3, negative 0.3, and end at 0.8. Except that, nothing else. And in the meshing, we are going to switch off this one, which are the baffle faces, as well as here. So now I'll rerun everything. Just to recap that we have created a run.sh, which is removing all the existing files and then doing the block mesh, then surface feature extract, and then overwriting. First thing, let's run this and visualize. Okay, I think we have to create this STL file as well. Gmesh, this is geometry, which is triangle, S2 form STL. Now let's copy triangle STL to constant trisurface. Now let's drag in this. Now you can see the new geometry is here, and now let's look at the surface mesh. You can see that the layers has been created and they are nicely created in this corner as well as in this corner, but probably it's not created well here. You can see similar to what we have seen. Let me make this 2D first along Y and then make it 2D. You can see here that the layers has been cast. We'll create a very small surface here and make this internal face again similar to what we have done in the previous case, and see if we can capture the layers in this corner as well or not. We can do that by just again creating this particular file. Right now this is at 0.8 and another point we want at, let me just confirm where we are here. Here we are at 0, -1 and 0.8. The other point will be at 0, -1 and point, let's say 81. And again we'll create the mesh, gmesh pl.geo, and then pl, move pl.stl to constant trisurface. Let's first visualize this particular STL file in constant trisurface bl.stl. It's here, which looks wrong. I think we did some mistake. Let's go back to the STL definition. This should be positive. Now let's again create the STL file and then move. And now we'll directly go to the SnappyHexMesh and use this STL file and similar procedure, and then the baffle left. This name should be same as what we have here, and then in the layer addition we have to add layer on both sides here. Remember that this star means that it will add layers on both the master side as well as the slave side. Again I'll run this, and here at the end you can see that whether the layers has been created or not, and clearly that these layers has not been created. Let's see what was the problem. On the airfoil, it was created 99% that whatever was the target, those many layers were created almost, but here none of the layers were created. Let's see the problem. First, let's visualize the mesh. Let's open the STL file. It's here, and let's visualize the surface, the mesh with the resolution, mesh with the edges, and you can see. But the mesh was not created, but here the mesh has improved compared to the previous case. Let's also visualize the edges here in the STL. It's something like this. Clearly it should have created here. Let's try to change one thing, which is the element size on the internal faces. Let's set that same as what we have in the airfoil. Airfoil is just the tag, it's not an airfoil actually. And run again. So again, no creation of the layers. We'll just undo this and try making this particular geometry a little bit bigger. So Gmesh and then move and again run. You can see now the layers has been created. Sometimes the surface that you have passed is very small such that it cannot create the snapping there. So if there is no snapping, then there won't be any layers. With this, you can see that here we have the required layers at the corner. Let me change this to 2D to visualize this. We can try making this surface little bit smaller if you want the layer just to be here only, or we can make this surface to go all the way to the end such that we have the layers till the end. There are options you can choose depending upon what you are simulating. Now let's try the another kind of geometry, which is a skewed triangle. That means the geometry is same as here, but this point is somewhere here such that we have a skewed triangle. And let's see what happens to this layer generation and how we can fix that. I'll change the geometry here. First the triangle, it's negative this, and now the point here I'll make a translation in x direction, and this one I'll change to a value which is not that high. It's a negative 0.2, and using this I'll create the geometry. Now I'll first remove whatever we have for the baffles. And we are not going to read the baffle face at all. Now I'll first create the mesh for the triangle, then move the triangle to constant tri-surface, and then run the. Let's see here, 94% created. Let's see where it did not create. You can see it did not create on the sharp corners. In order to show you that sometimes it does not create a good mesh here as well, I'll just change this, which is the surface feature angle, to something else. We are going to try the following change such that we do not have a good mesh on the surface. We change this to the number of layers to say 20, and this will change to 0.3. Let's also change this to say 4, and this one also we are going to change this time. We are going to change this to 5, and let's try meshing now. Here, let's reload this, and you can see that even though this is not a sharp corner, it did not create a very good layers in this corner. We are not going to talk about these two. These two you know how to fix, but this one you can still fix. In order to fix this, we are going to look here. in the surface feature extract, we are considering angles that are included are below 120 degrees. If I change this to 170, that means almost straight angles, then run this. Now if we check the mesh, it is little improved, but still it is not capturing this. Let's try one more thing, which is clearly this did not fix the problem. We'll again try the baffle geometry. Let's do that. The number one point we are going to take is this, which is this point, which is here, 0.1 and negative 0.3. And the other point we are going to take is straight in the y direction. Taking these 2 points will create this baffle geometry. Let's also visualize this. So the geometry is somewhere here, right at the corner. Now let me do the meshing again. Let me activate first the baffle geometries. It was here. Now again 92%, and let's see if it fixed the problem. Again no change. Now we'll try to add layers here. The layers are here. First of all, I think we were not reading the geometry. Let's try with this. So it was at 92%, now it is 94. Let's observe now, reload, and clearly it improved. Without adding any layers at the baffle geometry, we were able to capture these layers perfectly. Let me also show you, if we change this angle at the surface feature edge to the old angle, what will happen. You can see it was like this now. This one, it was like this before, and let me reload the current version. So you can see it is not even capturing that particular corner nicely because we are not capturing this feature. Again, if I just include that angle, again run this, again reload, and you can see it is capturing that corner as well as creating the layers over that corner. You can see how this particular parameter can affect the feature that we are trying to capture. With this, we are going to stop. In the next lecture, we'll try meshing some 3D objects, and I'll show you that what kind of geometries are difficult to mesh using SnappyHexMesh, and we'll talk about another meshing tool which is open source. See you in the next lecture. If you like the content of our channel, then please like, share and subscribe. Thank you.